Good morning. Today will be in English because maybe some foreigners, some scientists from other country like to listen and like to see details concerning Egyptian flints. The reason of this lecture is examination of flints in Tel el Farkha, famous archaeological site discovered by Italians and next explored by Professor Ciałowicz from Jagiellonian University in Krakow. And in this expedition, I participated in this expedition, so by the way, I work on flints. Not on typology, only on genesis, structures, internal physical phenomena, and so. And some words about this. The main problem is the origin of flints in delta, where are only clays, silts, and there are no coarser material, and comparison of flints from other siliceous materials from Tel el Farkha were done using data from gravels containing flints present at Valley of Nile Valley. The best place for the examination of flints, there is a region of West Theban, King's Valley, and so on, because there is one of the highest hill at this area. It's called Cime. Cime is probably from French language, and the place is there. There are Theban limestones, these symbols. Next we have Pleistocene, Pliocene gravels and younger sediments. Situation look like this. There is Valley Deir el-Bahari with temple of Queen Hatshepsut, and with temple of Tutmosis III, and samples as a material for comparison were collected from this profile, rocks present over both temples, and at this profile were discovered 28 horizons of flints, various. They obtain numbers, these horizons and flints, and numbers are going from the bottom, contact with Esna shells, because there are Esna shells, up to the top of Cime hill. There is King's Valley behind this mountain. The detailed examination of collected samples from the lowest up to highest show the variability of flints present at Eocene limestone, Theban limestone. There are examples, small plates, polished, and so on, investigated, of course, and there are primary horizons of flints. You see how these flints are differentiated. There are various colors, various structures, various cortex, and going from border with Esna shells up to top of Cime, we have this sequence of flints. It's important because these flints are later redeposited to the secondary places And of course, Paleolithic and Neolithic men didn't collect flints from hard limestones. They collected flints from gravels. So there are examples of Theban flints with characteristic structures, and it's chalcedony and quartz, slightly coarser grains of quartz, and calcitic, small calcitic grains, these color grains. There are fragments of mineralized organisms, various, mineralized mostly by chalcedony, but by quartz too, and various. There are fragments of sponga, some fragments, needles of sponga were mineralized with calcite or mineralized with siliceous material, chalcedony, and next example. But generally, in most of flints from this profile, limestones contain flints with a small admixture of carbonates. There are examples of mineralogical examination of flints from this profile, from La Cime profile, and there are examples. Tel el Farkha is generally name of problem of Temat, and this is the Egypt Theban limestones flints number 1. Macroscopic features, mineralogical features, mineral composition, grain size composition, and chemical analysis, results of chemical analysis of flint number 1. This means this is flints present slightly above contact between Theban limestone and Etna shells. And there are mine components present in percents and trace elements present in ppms. These analyses were made using atomic absorption spectroscopy. And this is next example of Theban limestones, flint number 2, the same analysis. Most of flints shown on this photograph were examined using these mineralogical methods, chemistry and microscopic. So, in conclusion, we can say that at La Cime, at the region of Kings Valley, are seen limestones, these Theban limestones, present over Etna shells, contain a lot of horizons of various flints. In Pliocene, next geological phase, stage, limestones of course were eroded, and on the base of slopes were formed slope gravels, Pliocene gravels, which were source of flints too at secondary position, because flints falling down from Theban limestones and were collected as sediments at the base of slopes on the border between Theban limestone and Etna shells. And next stage, Pleistocene and Holocene, was next stage of erosion of Theban limestones, as well as of these Pliocene gravels, and were formed new generation of gravels with flints. all flints are originating from Theban limestones. They are collected at first, second position, at second position, and at third position at the shores of Nile Valley. This is Nile Valley. This is Nile Valley, and this is place where Nile is present now. On the basis of examination of various types of flints from Theban hills from La Cime, we did statistic, and dark green flints are present in 21%, light pinkish 36%, light grayish 21% again, other 21%. So the main flints are of pinkish color. This is a diagram showing the presence. This, of course, is composition at primary position. This means in Eocene, and at secondary position, these all types are mixed. And this is an example of Pliocene gravels present at the base of slopes of Theban limestones. It's not very specially interesting, but there are flints at secondary position weathered from redeposited from Theban limestones. And next, younger generation of sediments, there are Pleistocene sediments and Holocene, where are flints at third, fourth, and fifth position. And of course, the same flints are present everywhere. And for example, there near of the King's Valley, there are gravels, so-called younger and older pediments, formed at the beginning of Holocene, containing flints. Some flints are marked with these red arrows, and very young slope sediments containing each type of discussed flints. And this is near of Tomb TT 1152, explored by Tomek Górecki with me. I participated in this. So, slope sediments, very young, all types. So people can collect flints from various sediments of various age, but at all these sediments are present the same types of petrographic types of flints as are present at or seen at Theban limestones. What we have in Tel el Farkha is plenty of various types of flints. I show you dominating mine types, brown, reddish. This is because of oxidation of iron sulfides. The flints start to be reddish. It's of beige color, and this is wax, slightly transparent flint, most probably import, because in Valley of Nile there are no types like this. This type I know from Jordan, in Cretaceous limestones of Jordan. There are types of this flint. And Tel el Farkha, we have various types of flints. There is characteristic macroscopic features, gloss, transparency, cleavage, so mineral composition, grain size composition, and chemistry. And the next group, there are shown only selected types of flints. Gray in color, not this color is not the same. It's changed at some places in flint. Gray with light spots, and matte in color with rarest light spots. There are fragment needles of sponga mineralized with chalcedony and sometimes with quartz. There are no at all calcitic inclusions. And there is gray flint with very good cleavage, and it's rare in Tel el Farkha with cortex. So probably this implement probably was made not at Tel el Farkha, but was transported as implement to the site, because some of them were, these implements were made in situ, this means in archaeological site. And looking under the microscopy, polarizing light microscopy, we have plenty of various features of flints. This is structure typical for flints secondary after sponga. These structures are connected with the primary biological structures of sponga, mineralized later by chalcedony and small amount of opal. And at Egypt Tel el Farkha flint number 6, it's very homogeneous, very good for knapping, and composed mostly of fine quartz of chalcedony. And there is Tel el Farkha and next examples of mineralogical features of flint. Flint number 5 example, and color in ultraviolet light, and gloss, transparency, macroscopic features, mineral composition in percent, mostly chalcedony quartz. At flint number 5, it's plenty of various types, and grain size composition dominating very small chalcedony crystals and some quartz coarser, and chemistry. In chemistry, dominating minerals, there is calcium, element is calcium, and traces of sodium, etc. Everybody can look. And admixture of trace elements, zinc, traces of nickel, and so on. And it's flint number 6 from Tel el Farkha, and the same features, but now you see that it's composed practically only of chalcedony and very fine crystals. Near 100% there are grains smaller than 5 micrometers, very, very small, very good for knapping. And chemistry. It's a very interesting relation between internal structure of flints and features good for knapping, because internal structure of flints is well seen if one has practice, may say how look like the direction of growing of chalcedonic crystals. And the best direction of knapping is parallel to internal structure. This means to orientation of growing, recrystallizing chalcedony crystals. And those peoples at the past, they did not know about this, but controlling best directions of napping, they automatically nap flints parallel to the direction, to the best direction of crystallization of crystals of quartz, of chalcedony or quartz, because at this direction was relatively easy obtain blades and other implements they produce. And there are examples of edge of implements from Tel el Farkha with traces of retouche, and this retouche similar there. This retouche is down parallel to the orientation of small crystals of quartz present inside. So they did retouche from this direction, and they did this parallel to the orientation of chalcedony crystals, which is according to this line shown by this small arrow. And this was the reason of the best work of implements, because it was important to produce implements using flints, produce implements which will work very well a long time. And they knew in the past that the best edge, very sharp edge, is parallel to the orientation of microcrystals of quartz. They, of course, they did not know mineralogia, and they didn't use microscopy, but they controlled the direction of the napping, and according to the knowledge, to the determination of the orientation of internal structure, they produce retouche of, and later they use the implements for cutting, screwing, and other works. And this is trace of yellow arrows, the same, show the damage edge of implement, damage during the work, of course. Other type of siliceous materials present in Tel el Farkha, there are small fragments of flints, as well as small fragments of agates. They collected agates. Of course, agates were not collected in Delta. They collected them somewhere in the desert, and later bought, this means flints as well as agates, they use as cores for preparation of blades, small blades and other products. There are cores with traces of napping and production of implements. Under the microscopy, these agate cores look like this. They composed of chalcedony, but of other type, present as look like under mineralogical microscopy. And other agates look like this. They have very symmetric internal structure, many generations of small quartz, it means chalcedony, and generations of iron oxides, this slightly brownish. So some flints, some conclusions concerning investigated flints. I will not read this for you because you can read yourself slowly, and each time you may come back to slides and to this small lecture and listen details. So I'm nominating three type of flints, and in delta I'm dominating. Okay. So next conclusion about Tel el Farkha. So thank you very much for listening, and I hope some information will be helpful for you, for your work, for your ideas, etc. Thank you, and masalama, how say our Egyptian friends, masalama.